Hi viewers, how are you all? Myself Nagappa, you are watching Appa Chemistry classes, and now onwards we are going to start the named reactions. These named reactions are very important. For every day you will get the named reactions. On each named reaction you will get the detailed examples and detailed information you will get. So till now those who not subscribed, please do subscribe, and let's get into the video. That is, in today's named reactions are Finkelstein reaction and Swarts reaction. These two reactions are very important. So these two reactions are examples of halogen exchange reactions. Now what are the examples and what type of reaction those are? Those we are going to see. Now here Finkelstein reaction is there. So what is meant by Finkelstein reaction? This reaction, Finkelstein reaction, is used to convert the alkyl halides like alkyl chlorides, alkyl fluorides, alkyl bromide will be converted to alkyl iodide when they react with the sodium iodide in presence of dry acetone. Why we have to take the dry acetone? I will explain here. Now once you see here, we have taken the ethyl chloride. This is ethyl chloride. Whenever it react with the sodium iodide in presence of acetone, then what happens? This halogen was exchanged by this halogen. Then what happens? We are getting CH3CH2I plus NaCl we are getting. So it is what we are calling halogen exchange reaction. The halogens are exchanging from the attacking reagent and leaving reagent. Now you compare the here bond strength between this carbon to this iodine and this carbon to this chlorine. This bond is stronger bond. This bond is weaker bond. Is it or not? So here strong bond is breaking and weak bond is forming. How it is possible? Now you see here acetone. This is what acetone. Whenever this acetone reacting with this iodide ion, now this iodide ion is there, no? So here chloride ion is coming out. That chloride ion will have the negative charge. So that chloride ion is having the negative charge. This negatively charged cloud is repelled by this acetone. It is a dry acetone. Why not wet acetone? It is an aqueous acetone because here sodium metal is there. Explosion takes place. So for that reason we have to take the dry acetone. Now then what happens? This oxygen with this chlorine repulsions takes place. So then what happens? This chloride ion is separated from this alkyl group readily due to presence of this acetone. Acetone is a solvent which repelled the halide ion which is present here. So which is repelled and the bond becomes weaker and the chloride ions are readily we are getting. And also this acetone does not allow again the chloride ion to attack here because chloride ion is more reactive than iodide ion. So then what happens? It will repel and this chloride ion combine with sodium ion and we are getting the solid precipitate of sodium chloride. So according to Le-Chatelier principle, more number of chloride ions are released. Then what happens? Precipitate formed will be taken out. Then the reaction takes place in that direction. Now which type of reaction it is? A nucleophilic substitution reaction. Which type of nucleophilic it is? SN2 reaction. Now you see here I am explaining with an example. Now I have taken the 2-bromobutane. It is what? 2-bromobutane. 2-bromobutane. When it is react with acetone, say for example this bromine is present in thick line. Whenever it react with the sodium iodide in presence of acetone, then what happens? We are getting the 2-iodobutane we are getting. 2-iodobutane. 2-iodobutane with inversion configuration. In SN2 reaction what happens? Inversion configuration we are getting. That is, the rate of reaction depends on both alkyl halide as well as the concentration of sodium iodide which we are taking. The concentration of sodium iodide should be more and as well as alkyl halide also should be more concentrated. Then only we are getting this one. Is that clear? And also here thick line, here dotted line. Say for example it is an S configuration. S configuration. So then what happens? We will get the what? R configuration product. That is complete inversion takes place. That is what we are calling umbrella effect. That takes place in case of SN2 reaction. So Finkelstein reaction is an example of halogen exchange reaction. So how the halogens takes place, exchange of halogen takes place according to SN2 reaction mechanism. Now we had seen by using this Finkelstein we are going to prepare only alkyl iodide. Now you can take the another example also. It is a cyclohexane. So which is having one chlorine. Now here the chloride ion is substituted with a dotted line. Whenever it reacts with the sodium iodide in presence of acetone, then we are getting cycloiodide we are getting with a thick line, And also you can take in the terms of Fischer projection. Say for example chloride ion is there, here CH3 is there, here hydrogen is there. Whenever it reacts with the sodium iodide, then what happens? That iodine will be attacked from the back side, not from the same direction. Because it is in the same direction, what happens? Repulsions will be there. Then we are getting umbrella inversion product, that is hydrogen. So here CH3, here it will be. Okay, na? So what happens? The iodide ion is attacking from the back side. That is what we are calling Finkelstein reaction. Next we are going to see the Swarts reaction. This Swarts reaction mainly used to prepare the halides, fluorides, alkyl fluorides. To prepare the alkyl fluoride, we are using Swarts reaction. What happens in this case? The alkyl halides, whenever they are heated with this metal fluorides, say for example silver fluoride, upon heating, then what happens? We are going to get alkyl fluoride plus silver halide we are getting. Okay, na? So silver halides will be precipitate. That precipitate formed will be taken out continuously. Then the rate of reaction towards the forward direction. Is that clear? So now you can take the, say for example I am taking a ethyl bromide, CH3CH2Br. Whenever it reacts with silver fluoride, metal fluorides like silver fluoride, cobalt fluoride, or antimony fluoride, or mercurous fluoride, by addition of this metal fluoride, these all will be inorganic metal fluorides. By adding inorganic metal fluoride to the alkyl chloride or alkyl bromide or alkyl iodide, and upon heating, then what happens? We are getting the alkyl fluorides. Generally, the preparation of alkyl fluoride is very difficult. So by using Swarts reaction, we can prepare the alkyl fluorides, and we are getting the silver bromide as precipitate, yellow colored, light yellow colored precipitate. And also you can take the other example here also. The substitution of fluoride ion also takes place according to SN2 mechanism. Is that clear? So that is what Swarts reaction. You can take another example also here. Now if it is chlorine is in thick line, whenever it reacts with mercurous fluoride upon heating, then we are getting the alkyl fluoride along with mercurous chloride, we are getting Hg2Cl2. Is that clear? That is what we are calling halogen exchange reaction. That's it, Finkelstein reaction and Swarts reaction. By using Finkelstein reaction, we are going to prepare the alkyl iodide. By using Swarts reaction, we can prepare the alkyl fluorides. Both are takes place according to SN2 mechanism. Both are nucleophilic substitution reaction. I think so. You have understood. Thank you. Have a nice day.